Anything? Anyone know what a trigonometric function is? Get in there. Okay. Yeah, sine and cosine stuff? Okay. So if you don't know, it's fine, because we're going to talk about it. We're going to learn it. I just wanted to see if anybody knew anything about it. Whenever we learn a new function, can somebody tell me, I've said something several times, when we learn a new function, what do we do with it immediately? Several things we do with it immediately. When we learn a new function, what's one thing we kind of do with it? Say again? Transform it. Sure, yeah, so graph it, right? We want to know what the base function looks like. We want to know what the hell this thing looks like. So then we can transform it if we need to, right? So we graph it just to see what it looks like. What else? We find the... Okay, domain and range. That's related to the graph. I love it. But we also find the inverse, right? Now real quick. What is the inverse? Just tell me, what's the inverse of x plus 7? X is crazy. All right, so the inverse of addition and subtraction. So why is that important? Because if I didn't know the inverse of addition, could I solve that? Can you guys all see that, my poor little green marker? If you can't, let me know. Okay. You guys with me? That's kind of silly, isn't it? Of course I have to know subtraction to be able to do this, because I got to subtract 7 to see what the hell x is. So, why are we so curious about inverse functions? Because if I have that function in an equation, the only way I can solve the damn thing is to do the inverse, right? So, how would I solve something like this here? Can I write this? Yeah, can I write this as the inverse? This says 3 squared is x. X is 9. I'm done with that problem. Next. So we use the idea of the inverse. The inverse of a log is an exponential. Okay, maybe. How about this one? There's one. The log base x of 4 equals 2. Sure. Right. This says x squared equals 4. And then you take a square root. I love it. Now normally we would put a plus or minus, and the reason we don't take the negative is the base can't be negative. So this is x is 2. So if they give me an equation with a log function, I can rewrite it as an exponential. How are we doing so far? And we've done this kind of thing. We've kind of done it. We set it equal to x, and then we rewrote it. So it's that same basic idea. But again, I'm using the inverse to help me solve the equation. Okay. Maybe. So what about this? How do I rewrite this? So 3 squared equals x plus 1. So x plus 1 is 9. So x is 8. Okay, now, let me just stop for a minute, please. Do you guys all see this? This is why it's important to know how to rewrite a log as an exponential and vice versa. Okay. These are nice, aren't they, so far? So far. So let me show you the first level of stuff I can do to you. Okay. Let's see. I'm going to take these out here. Okay. So what do you think you would do here that, Jeff? Sure. Okay, sure. What is the main difference between this problem and that problem? How many logs are in this problem? What? I can directly change that one log into an exponential. How many logs are in that one? Damn! If only that wasn't there, I could just do the same thing we just did, right? Damn it! If only I had a way to make those two logs become one. Do I have a way? Yeah, when I subtract logs, subtract powers, that must have come from division. Right, so all the properties of logarithms are the same as the properties of powers. So what are logs again? Can somebody just tell me? One word.
Power.
Powers. So every property of logs are properties of powers, because logs are powers. So when do I subtract powers? When I was dividing. Now do I have a single log? Yes. How do I rewrite it? 2? How? 2? 2 done? To the first? Equals? X plus 1 over x. I just like to put my variable on that side. All right, besides the fact that it exists, what sucks about this equation? What's the worst thing about this equation?
There's 2 x's.
Say again?
There's 2 x's.
Yeah, what's even worse is where's one of them?
The bottom.
On the bottom. Holy shit, so can I do something about that? You guys agree if it was this, that would so kick ass, right? But it's this, damn you! So I don't like the x on the bottom, so what do? Yes, multiply by x, right? So when you have an equation, in general, if there's something about it you wish wasn't there, you very often can make it not be there, right? You just do the same thing to both sides. So if I multiply this up by x, multiply this up by x, bam, bam, I get x plus 1 equals 2x. And then I'm one step away, right? Now I just have to or all your x's together. Subtract x, right? So you get your x's together. X is 1. Now I don't know if you guys remember, when we have square root equations, we have to check the answers to make sure it doesn't freak anybody out. You have to do the same thing with logarithms. So if I throw a 1 back into the equation, does it make anything become undefined? What can log not handle inside of it?
0 and negative.
Zeros and negatives. So if I put a 1 in, does it make any of the inside 0 or negative? No. So it's not, I don't have to throw it out. Remember we had radical equations? And if I threw it back in and made it negative inside, I had to throw it out? Or if it made it not work, I had to throw it out. Right? Okay, so this is fine. In fact, if I check it, what's log base 2 of 2? Right? Throw a 1 in. What's log base 2 of 2? 1. What's log base 2 of 1? 0. And 1 minus 1 does equal, 1 minus 0 does equal 1. Sweet. So you can check it like always. Yeah. It's kind of nice. I really want you to understand. If there's a single log, kick ass. I can rewrite that and then solve it. If there's 2 logs, no problem. I just put those logs, make it 1 log, and keep going. Okay, so you guys try this one. All right, this could be exciting, Jeff. Let me see. All right, this is going to take a little bit of thought. Let me see. Okay. It's short. All right. Try to make one that works nice. Try to do the first couple steps of this one. Be really careful. Why did I write this as a quotient? Because it was. Why did I write this over this? Because it was subtraction up here, right? Works the same way, except you have to use the appropriate rule, right? So how can I rewrite this?
X minus 1 times x plus 5.
Yeah, I add powers when I was multiplying. I like it. Let's see if I made one that works. This is always exciting. So you can do one of two things next. Does anyone have an idea what the next step might be? Why did I do what I just did? Because if there's a single log, I know how to continue, right? Did we just make this into a single logarithm? Yes. So what can I do next?
Multiply.
Yeah, good. Okay, I like it. So you can multiply in here. And now what's the whole reason I made a single log? So I can do what? 3 to the third power equals this business. So we learned all those properties of logarithms, and we sort of had some examples that showed why that might be good to know. But now we really see why they're good to know, right? Because now we're able to solve equations with them in it. So now it's a question of, do you remember what to do here? Yeah. Does someone else tell me, what is it about this problem that tells me I can't just solve for x? Yeah, there's a square on it, so I have to get it equal to what? 0, so then I can factor, right? So again, let the problem tell you what to do to it. There's a higher power than 1 on one of my x's. All right, I want to get it equal to 0, so I can factor it and get the answers, right? So subtract 27. Is that factorable?
I hope so.
Me too. You weren't here earlier when I made this out of my head, and I'm like, please work. It looks like it will work.
8, x minus 4.
Yeah, x plus 8, x minus 4, I like it. So what are your two answers that you get?
X is
Negative 8
positive.
and 4. Now right off the bat, which one of those do we have to throw out? For sure.
Negative.
Yeah, doesn't negative 8 make that negative?
No.
Right? And it makes that negative too? You guys with me?
Yeah.
I really, now again, okay, stay with me now, stay with me. And logarithms can't handle negatives on the inside, correct? So, as a student, if you're really paying attention, you should start to get a little upset. You're like, why did math give me a freaking wrong answer? It's your problem, math, right? I did this whole problem right, and you gave me a wrong answer. Ah. Well, look what we did. It was the very first thing we did. We multiplied these together. If they're both negative, it becomes positive, correct? So then math says, oh yeah, this has answers. I really want this to make sense. If these are both negative, don't they become positive when I multiply them together? Okay. So math says, okay, good, you did this. Here's your answers. And we're like, oh shit, I can't use this one. Math didn't know. Math didn't know shit. It just does what we want it to do. And maybe. I always want to be careful about that because it's, as a student, I imagine it must be frustrating to not only understand how to do something, but then every now and again, you get a wrong answer even though you did everything right. So I really want you to understand why that isn't math's fault. Okay. What about the other one? Does it seem to be okay? Does it make anybody freak out? Nope, they're both positive, right? In fact, let's check it. This is log base 3 of 4 minus 1 plus log base 3 of 4 plus 5. What is log base 3 of 3? 1. What is log base 3 of 9? 2. And does that equal 3? Yes, so you can check your work like always. Kick ass. So as long as you understand those two basic properties of logs, when you subtract, it's the log of the quotient. When you add, it's the log of the product, right? You're golden. Okay. So, what about an equation that has exponents in it? Exponential functions. And by the way, real quick, I was thinking about saying something about this. Why do we care so much about solving equations? Not just in math, but just period. Does anyone have an idea? I mean, so much in math. What do you do the most in any math course you've ever taken? Solve equations. Am I right? Yes. Second thing maybe is graphing stuff, right? But the thing you do almost all the damn time is solve equations. Why? Why do we give a shit about that? Does anyone know? So when do you remember there was a hurricane that actually skirted off the coast and we were affected by it? You guys remember that? So this will actually be more, I used to live in Florida. Thankfully I escaped. And then we moved to Virginia. And I was born in Georgia. So all of those get a bunch of hurricanes, right? So when I look at the forecast and I see where it looks like the hurricane's going, they had to set up equations. Now listen, didn't a computer do a lot of the calculations? Right? And let me stop. Have you ever seen a hurricane track? Have you guys ever seen the little, it looks like they got the little hurricane symbol, and it's got like this cone. And it's got this line down the middle. Yes, maybe? Has anybody ever seen that? And then here's Florida. And we're all like, oh shit. Right? And of course, if you're a certain president, you kind of Sharpie where it's going to go. Anyway. A computer crunched the numbers and got this. But who told the computer what equations to frickin' use to crunch the numbers? We did, right? So equations come from observations in the real world. And if I want to make predictions based on what I've seen, I've got to set the freaking equation up. Nowadays, we got computers that just chomps on the equations. Back in the day, we had people chomping on the equations, right? But I really want you to understand, I don't know if anybody's ever just had this discussion with you. Why do we solve so many freaking equations? Because that's what we do every day, right? Your smartphone, of course, that's the teacher's go-to. There, your smartphone wouldn't exist. But it has a bunch of equations that it solves to do anything it does. And who programmed those equations? We did. We got to know what goes into those equations, and then we program it, right? Maybe. Okay, I'll stop. Okay, go away, Florida. Okay. So, coming back to just straight up math, if I have something like this, blah, 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 blah. Let's do, all right. We've done something like this already. So if I have an equation where the bases are related, what can I do? What would you divide by? Say again? All right, let's try it. Let's divide by 4. So I'll do that side, right? Okay.
What about the X still up there?
How many 4s are up top?
X.
X of them.
Yeah.
And how many 4s am I dividing?
Not 4.
One of them. Yes? Is everybody with me?
Yeah.
Real quick. This is not the correct thing to do. But what do we do when we're not sure? We just try something. It's not a damn thing wrong with that. Oh, by the way. Okay. Remind me, real quick. What is x to the 7th divided by x to the 4th? X to the 3rd, yes? Okay. So what would 4 to the x divided by 4 to the 1st be? Yeah, so that did nothing for us, right? It's legal. You could do it. It just doesn't do anything for you. Okay. All right, so let's not do that. But I really want you to understand, if you have an idea, try it. Because then you start to learn more. If you see what doesn't work with the idea you had, then you're like, okay, that's why this other way is better. What did we do? We've done this before. What are they both based on? 2. So what's 4? 2 squared. And 8 is 2 to the 3rd power. So you multiply power. So what must be true in order for 2 to something to equal 2 to something? What must be true about the somethings? They have to be equal. Does everybody cool with that? The only way that equation is true is if 2x equals 3. So the next is 3x. Okay. And why does it make sense? Because what is 1/2 of 4 multiplied? It's the square root of 4. 2. And what does 3 of those make? 8. Right, so that's 4 to the 3/2. Sure enough is 8. So, you guys do this one real quick. Yeah, all right. Let's do. I can do it. What about? Sure. 16 to the x equals 64. Oh, that's better. Go ahead and solve that. I wouldn't use a base of 2, by the way. Yeah.
Oh, that's exactly equal to 2. Because like 16 is 4 squared and
Yeah, base it on 4.
but can it be smaller?
What's up?
Can it go smaller or no?
You could, but I don't want to. If I go smaller base, the power gets bigger. That's messier, right? So 16 is 4 squared. What's 64? 4 to the 3rd power, right? So then what must be true? 2x equals 3. It's the same thing. Yeah. Say again?
I thought 4 to the 4th is 64.
Oh shit, no. All right. Gotcha. Understandable. Okay. How are you guys feeling about this so far? I mean, this is actually old news. So the log stuff was sort of new, but it's just rewriting logs. We know how to do that. This is not new. In fact, if the question was log base 16 of 64, right? Wouldn't we set this equal to x? And then 16 to the x equals 64? I mean, this is what we've done before. We've done this before. So nothing amazing. So the real question now should be, all right, Jeff, what if you just make up numbers and they have nothing to do with each other, right? Why is this doable? Because they're both based on 4. So what if I had this? Why do it, Jeff? Because it can happen. I'll just start over with one. Anything. 11 to the x equals 72.3. Yeah. I like it. So, are they both based on something? Shit, no. Do you understand what I mean by based on something? 16 is based on 2 and 4. 2 to the 4th, 4 squared. What's 11 based on? I don't know. 11 is itself, right? I don't know. So how many 11s does it take to make 72.3? Does it take a whole number of 11s? What's 11 to the first? 11. What's 11 squared? 121. So isn't the answer going to be between 1 and 2? 2 is too big, 1 is too small, so it's going to be in between 1 and 2. You guys semi with me? Okay, okay. So what the shit? What the shit, Jeff? What do we do? I can't do this. I can't do this at all. What is really wrong with this is where is my variable? It's in the exponent. Do we have any function that if I apply it, that can come down? Because what's the big problem is I need to be able to get x by itself. Right now it's stuck up here. I need to bring it down so I can do anything, right? So do I have a function where the power will be able to come down? Is there anything like that? See it? Any log, yeah. So normally what I use is natural log. It really doesn't matter what you use, because every log has the same property. The power on the inside comes out front, right? Why do I use ln? Why do most math teachers use, or mathematicians use ln? Because it's got the fewest letters. It's just an L and an N. It's only 2 letters versus 3 for log. That's really... Plus, if you happen to have your calculator, look at the face of your calculator. Don't you have log and ln? So you can very quickly figure out what those are. You can figure out what natural log of 72.3 is. It's right there, right? So what? Now that I've done this, what am I able to do? What can I do with this? Not get rid of it. Bring it down. What is the, all right, don't try to tell me the answer. Well, what is the natural log of 11? It's a number, correct? It's a number like 2. It's not as pretty as 2, but it's a number. That's all it is, correct? Same with natural log of 72.3, right? So I basically have 2x equals 7 or something. How do I solve for x? I have a number times x equals a number. How do I solve for x? Divide by what? ln of what? 11, because you want that to die, so you get x by itself. So don't freak out about ln. You don't have to know what ln of 11 is. It's a number. You want to get rid of it. I want x by itself, like always. All right, let's see if you guys, I didn't bring all the calculators today, sorry, but if you have a calculator, see if you can plug this in. Let's see if you can get what this is. Huh? Sorry?
It's almost 2.
Oh, it's almost 2? Okay.
Like 1.78.
Sounds about right. Let's see what everybody else gets. You guys get that? So obviously on these kind of problems, I would tell you what's around 2, because doesn't that just kind of keep going?
Yeah.
So, rounded to the hundredths place, it's 1.78. Okay. Because what's the next number? 5? So I'm going to round to the hundredths place, what should it be? 9. Okay. From our work, what is that number supposed to do? I love that question. Such a weird question. From what we've done, what should that number do? Remember, the original problem was, because I did shit to this, 11 to the x equals 72.3. That was the original problem, correct? So what is this number supposed to do? When you raise 11 to it, yeah, try it. What is 11? Now, it won't be perfect, right, because we rounded this, but what is 11 to the 1.79? Should be a little more than 2. Or, I'm sorry, a little more than 72.3. What do you get, 72 point? Say again? 73? Okay, so a little more than this. Why does that make sense? Because again, we rounded this, didn't we? In fact, we rounded it up a little bit. But now you can still check your work, right? So that is the power that 11 needs to become 72.3. And it's between 1 and 2, like we said. 2 would make it 121. That's too big. 1 makes it 11. It's too small. Maybe. Let's do that same problem again, real quick. Well, let's use log this time. You guys see your log button, those of you with your calculators? Right? You guys see the log button? Mm-hmm. So it's all the same work, right? So now we're using log. It's log. It's log. So what's log here? What's this mean? Log base? 10. Okay. So try that. It better be the same number, or else math is shit. We can throw it all out. We can go. Let's do it. Are you guys getting the same number? Those of you? Yeah. That should be a little freaky. That should be a little freaky. Because over here, this is log base E. And over here, this is log base 10. But somehow the ratio came out to be the same number, right? 1.79 roughly. Okay. All right, so let me do this. So I promised you, I don't know if you guys remember, but I was talking to one point to somebody about the change of base formula showed up too early. Now I can talk about the change of base formula. I can prove it because now we know how to deal with these equations. So let me prove the change of base formula. And why do I want to change a base formula? I'll show you. What if I ask you, in your calculator, some of you guys might know how to do this, but we'll see. In your calculator, can you please do log base 17 of 5.9? Can you do that? Do you have a log base 17 button?
Yeah, go into the math section.
You have to go to the math section. I love it. Now, back in the day, that wasn't even there. So let's do that. I'm still going to show you change of base. So watch this. I'd much rather be able to use log or ln because that's on the face of my calculator, right? You guys with me? I don't want to have to go into some menu. So watch this. Anytime in math that I don't know what something is, I can call it x. Cool? Okay. And then I can rewrite this as what? Sorry, I just wanted to say, is that where you go? So 17 to the x equals 5.9. Now I can use whatever log I want to solve that, right? So now if I do natural log of both sides, what happens here?
X goes to the front.
Yeah, it goes out front. And then I can just divide by this, right? Now, real quick, if that was a 0, 17 to the 0 would be 1, right? If that was a 1, 17 to the first would be 17. So it should be between 0 and 1. The answer. And I'm going to say, don't say it yet, let me think. It's going to be like, shit. I'm gonna say like 1.8.
What?
I don't know, or 0.8, sorry.
The answer?
What is it?
0.6.
0.62?
0.626.
So 6.3, okay. Alright, not too bad, I guess. I'm a little disappointed in myself. So, what did we just do? We just did this. We just discovered that log base 17 of 5.9 equals this. Natural log of 5.9 over natural log of 17. So in general, log base anything of something is natural log of the something divided by natural log of the base. And like I said last time, this is relatively easy to remember. If you remember, base goes on the bottom. Base on the bottom. Okay. Maybe? So if I had, for example, log base pi of 11, how could I rewrite that? ln of 11 divided by ln of pi. And whatever the hell that is. I'm going to say it's about 2.1. I don't know. Somebody help me out. Maybe it's about 2. I don't know. 2.09? That's pretty good. Look at that. All right, sorry. Yeah, it's back, baby. All right. sorry. That's just a fact. We sort of proved it there, that's what happens. So now in general, now you see why it's called the change of base. This is a base of B, this is a base of E. I just changed the problem from a base of B to a base of E. Now watch. It really doesn't matter what log you use here. So let's try this. What is log 11 divided by log pi? So if you do that, what's log 11 divided by log pi? 2.09, yeah. Okay. So I can take any base log and change it into any other base I want to, and normally we make it one of these because they're the ones that are on the face of my calculator. They're the easiest ones to use. Okay. So that's the change of base. They brought it up too early. Too bad for the book. It's a free book. What do you want from them? Now, coming back to these exponential equations. Everybody got that? We talked about it before, but we weren't able to prove it. Okay. I think there's a submarine pinging us or something. So, what about, well, I'm going to ramp the level of difficulty up. And this first ramping is not that big of a ramping. 7 to the 1 minus x equals 2. I like it. So the first thing I can do is, instead of just being x, I can make the exponent anything I want to. But we solve it the same way, right? So again, the fundamental problem here is my x is stuck up in the exponent. The only function I know that won't take it down is a logarithmic function, yes? So what do you want to do to both sides? Yeah, I'm going to take the ln of both sides. Because then what can I do with this? Right? right? Is that cool so far? So nothing's really different yet. Now the differences come into play. Now we got to be careful. Remind me, what is natural log of 2? I mean, I don't know what the number is, but it's a number, right? Natural log of 2 is just a number. So, can somebody tell me what might be a good next step? I'm trying to get x by itself. Subtract what?
1.
Subtract 1? No. I don't see a 1 up there. Because this times this currently, right? So you'd have to distribute, but I'd much rather just kill that ln7 right off the bat. Is that cool? Die. I'm trying to get my variable by itself. You have got to get over how funky this looks. Natural log of 2 divided by natural log of 7 is just a number. It's just a number. I don't know what it is yet, but it's just a number. So I got 1 minus x equals a number. What do I do to solve for x? Sure. So I can subtract 1. So I get negative x equals this. And then, why is x not by itself yet? It's got a freaking negative, so what do I do? Divide by negative 1. Dividing by negative 1, all that does is change everybody's sign, right? So this sign changes, so I get x equals negative this business plus 1, right? Or you can write it as 1 minus this business. So let's see, if you have a calculator, go ahead and try to do that. I think it's going to be 0.86. What do you think, Jeff? Do you think that sounds right? No? I don't know. 0.8. This one I'm not really sure about. That would be 1/3, so that would be 0.6.
0.64.
What is it?
0.64.
0.64, okay. Roughly. Is that what you guys got? 0.64 roughly? Okay. Maybe. No? Uh-oh. Let's see, do I have you gotta be a little careful with inputting these things. Input. Okay. Bum. There you go. Okay, so I want to do 1 minus natural log. See how it assumes a parenthesis? I kind of hate that. Natural log of 2. So you got to close that parenthesis. If you don't close that parenthesis, everything you write will be inside that natural log. You just want 2 inside there. Divided by natural log of 7, right? Yes. So 0.64 roughly, yeah. So if I raise 7 to the 1 minus that, if I round it, it should come out to be a little less than 2, or a little more than 2, sure. Oh yeah, because it's 1 minus. So I can still check it, but if I round it, it's not going to be perfect. So be really careful. I really hate when the calculator puts a parenthesis in for me. I'm like, I can do that, calculator. It's sort of like Microsoft Word guessing what I want. I'm like, no, stop it. I know what I want. Okay, maybe, I don't know. Okay, so let's see how bad these can really get. Let's do 0.8 to the 2x minus 1 equals, what do you got, Jeff? 3 to the x. Oh, shit. So obviously what's different with this one? There's freaking variables in the exponent on both sides. That sucks. All right. But the same thing will take care of both those problems, right? My variables are all stuck up there, so of course what am I going to do? I'm going to take the natural log. I like it. Any log you want, but natural log because it's got the fewer letters. So what's going to happen to each of these powers? They're going to come down. So this will be 2x minus 1 times this freaky dude equals x times this freaky dude. Okay. So here's where you really, really need to just let go of what this looks like. It's just a number. It's just a number. Right? So what should I do? How many x's do I have in this equation? Are there several spread around? Aren't there? Isn't there one here? And there's one over there. So how do I solve an equation? It's got x's in multiple places. I try to get them all on one side, right? So I better distribute this. So you guys see this. This has an x in it, and that has an x in it. So if I add this to that side and then subtract this, I'll get all my x's together, yes? We all know this. How do you solve any equation? You distribute and then get your x's together on one side, your numbers on the other side, correct? That's how we always solve any equation. So I'm gonna subtract this. I'm going to add this. Because now my x's are together. So those cancel. Those cancel. Now all my x's are together. Are these like terms? Definitely not, right? But isn't that what we normally do next, is we put our like terms together? Damn it! So how many x's are there at the moment? There's like 2 of them, right? There's one there, there's one there. No, there isn't. There isn't 2 of them. There's one. There's one. There's one right there. There we go. Can't I just take an x out? Right? You just take an x out. And then how do I get x by itself? Why is it not by itself? Because it's x times stuff. So how do you get rid of this stuff? Divide by stuff, right? So I'm going to divide by this. So x equals this. Does that look good? No, not really. It's kind of gross. matter. This, by the way, this is the exact answer. Because any decimal answer I give, I have to round it, don't I? Because it's going to go forever. So when I say I want an exact answer, you stop here. This is the exact answer. If I say I want an approximation rounded to 3 decimal places, then you put it in. Say again? Yeah, so let's go ahead and figure out. So this is the exact answer. Let's figure out the approximate answer. So I want natural log of 0.8 divided by, parentheses, 2 times natural log of 0.8, close those parentheses, minus natural log of 3. So I get that. So let me show you, just in case. Let me see. If you don't like at all what I'm about to show you, you never have to do it. You can do this problem just like this. But I've noticed some people really like this thing I'm about to show you. So I'm going to pick this up right here. You never have to do what I'm about to do. We finished that problem. It's done. We got it. Yay. So let me show you something that might help. This might freak some of you out, and some of you guys might love this. The worst part of this equation is the fact that I have natural log of 0.8 in there, natural log 3. I'm not used to dealing with it. In fact, real quick. If I said to solve this, what would you tell? Does this look okay? Does that look okay? No. That's sort of like me saying, solve this, and then somebody says, okay, I'm going to divide by the square root symbol. There you go, 11 divided by square root. I'm done. Is that good? Is that good? No, that's shit, right? So I can't, this is the natural log of this, not the natural log times this, right? I know maybe that seems really silly to some of you guys, but some of us just sort of forget that, and we just start getting rid of the ln. We can't do that. It's just like a square root. How do you get rid of it? Square. How do you get rid of an ln? Rewrite it as an exponential, right? Can't do that over here. So much. Okay, if you don't like this, again, if you don't like this, you never have to do it. What is the natural log of 0.8? Oh, hello. Okay, sorry. What is the natural log of 0.8? I don't know. So I'm going to call it A. What's the natural log of 3? I don't know. So I'm going to call it B. Now look at what my equation looks like. Why am I allowed to do this? Because I said what A is. So these are the same thing. It's just easier to look at now. Do you guys agree with me? So now when I distribute this, isn't this just going to be 2xa minus A equals xb? That looks a lot better, yes? So if you don't like this at all, never do it. Just do this thing, just do this way. So now I'm going to add A, and I'm going to subtract xb. So I get all my x's on one side. I can factor an x out, and then I can divide by 2a minus b. So I get x equals a over 2a minus b. But what was a? Natural log of 0.8. And what was b? Natural log of 3. Isn't that the same thing we got earlier, right? Of course it is. So that's a nifty little trick, is if I got something gross that I'm just going to have to carry, replace it with something less gross. As long as at the end, you put it back, right? Completely legal because A is natural log of 0.8. So of course I could do that. Maybe. That's probably the worst part of solving these equations, is just being okay with this shit just sort of sitting in there. And it just looks so weird. We're not used to it. All right, so here, you guys try to solve this. What do you got, Chef? Let's do 8 to the 3x plus 1 equals 21 to the x. Sure. All right. But just to let you know, in general, the very first thing I do is I look to see, can I make the bases based on the same number, right? If this was a 16, that would be awesome. But it's an 8 and a 21. Ah, shit. So I have to use logs. I can't do like we did earlier, make the bases the same and go from there. Yes? So try to do this problem. Just to make sure everybody's on the right track, I'm going to catch up to you a little bit. So we take natural log of both sides, so that this can come down. Here's my only good marker. And this is where you can make the choice. If you just want to leave it as it is, or if you want to do this little thing, it's up to you. Both ways are equally valid. I'm going to try to leave it the way it is, just to see. And just to give you guys an analogy here real quick. If I gave you this equation, that's written a little weird, right? But still, it's just, what would you do first to solve this? Let me write this a little more normal. Right? What would you do first? Distribute. Yeah, distribute the 2. All right, it's the same thing we do first here, right? Distribute the natural log of 8. Okay, And then what would you do next? Subtract. No, what's in the wrong place? Yeah, the x's need to be together, so I subtract 6x, don't want to give a like division. That's exactly what I'm going to do here. The x's need to be together, so let me subtract this. And of course now I'm trying to solve for x, so what would I do here? Are these like terms? You guys, does everybody see those are not like terms, right? I have x natural log of 21s minus 3x natural log of 8s. Those are not like terms. So normally I put them together because like terms, but instead I can just take an x out. And then of course, to get x by itself, what would I do? Divide by the stuff I don't want. Right? Cool. And then this would be the exact answer. And then you can throw in the calculator to get an approximate answer. Some rounded decimal. Yes?
When you combine the x's, does it matter which side you combine them to, left or right?
Oh, like taking the x out? Is that what you mean?
When we put ln on the right there.
So when I subtracted this away.
Yeah, so even if it makes her life a little harder because we didn't think about it.
You could subtract this and then subtract that.
Okay.
As long as you get your x's on one side, the non-x stuff on the other side. As long as you do that, you're golden. Okay. Maybe. Okay. I think I agree with you. I think that might be enough. Let's have a nice early day today. Right? Why not? Why not? So I'll be back in my study center if you want to come over there, work on some corrections or something. Or don't do any math at all. It's up to you. You're free. So next time we'll finish up chapter 6 and we'll keep going.